Turbo Dave 231 here. Today I'm going to make a quick video on repairing some threads in Buick cylinder heads. And what I got going here is I'm going to take the camera off of my tripod. I'm going to show you some threads in a pair of cylinder heads that need some help. This is an engine that I'm working on for a friend, and the cylinder heads where the intake manifold bolts on, I'm not sure if you can see, some of these threads are pretty gnarly looking, pretty messed up, and I'm afraid that when I go to torque the intake manifold that I'm going to pull what's left of these threads out of here. Okay, now the threads in these cylinder heads are not 90 degrees to this surface. They're at an angle. They come out of here at a 75-degree angle, and I'd like to thank Richard Clark for supplying that information off the blueprint. So I was able to make a fixture, and that's kind of what I'm going to show you here today. Is I've made a fixture to accurately drill and insert helicoils into all of those holes. Alright, here's what I got for you. I had previously made this plate here, and this plate is set up to do the exhaust ports on any Buick stock style cylinder head. So that would be the cast iron 445 heads, GN1 heads, TA heads, or M&A. If they all have that same, if they use a stock style exhaust manifold, if that manifold bolts to it, this fixture will work. And I'll use these two holes, and then these two holes. The other set of holes in this particular template are set up for small block Chevy, and they've got the correct spacing to do those when you get broken studs and so on and so forth. But these are pretty simple because the holes into the cylinder head are straight in. They are 90 degrees to the manifold mounting surface. So basically what we do here is you got to have two good holes. You put in a couple of bushings here and add the studs, add some washers and nuts, bolt the fixture down, and then that allows you to do the repair work on these locations. And what I've got here are hardened steel drill bushings. Now these, I get these from McMaster Car, and they fit right snug right in that hole, and it allows you to take a drill bit, the proper drill bit, and to drill, and I gotta get the right bushing here, and there we go, that's the right bushing. With that bushing in place, now we can drill out the existing threads and tap for a helicoil or for a time cert thread insert. Okay, this is for a helicoil, and this drill bit I believe is a 25/64 size wise, and the tap that you use is an STI tap, which stands for screw thread insert, and this one is actually a helicoil brand, and it says STI tap. It's not a standard tap. Okay, so this is of the previously made fixture, and then this is the fixture that I just made this week to do the exact same task, but to do it on an angled bolt hole. Now you can go ahead and try and do these freehand, but it is very difficult to get the center line of the new threads on the exact same center line as the old threads. In order to do that properly, I've done it on a seat and guide machine where I can level the cylinder head and tilt it in the right angle so it's on the same axis as a spindle, but really tough to do on a cylinder head sitting on a bench. So I came up with a system to do it on these angled holes. We're going to use the exact same setup here, but now the holes drilled in these little machine pads are at that 75-degree angle. Bolt on the head here, and now we're going to take our drill bushing, and then I'll be able to drill through the cylinder head, take out the old threads. The other problem that you're going to run into here is to tap at the same angle, because once you take this drill bushing out of here, this tap can wallow around, and you may not, because it's soft material, you may not get the threads on the exact same center line. So I thought about that for a while, and I came up with a solution for that, and that's this bushing here. And my tap fits right through it, and when this is held in place, the tap still is loose. But what I've done is I've made a bushing here, a bushing and a bushing, that's going to allow me to do the tap work and to maintain the exact same center line as the drilled hole. This is kind of going to make it idiot proof, if you will. But even an idiot can find ways to screw things up. I'm starting out with the Buick Power Source Manual. These things are out of print, hard to find, and in my opinion, invaluable information in these books. And here's where I got the information on where to make the plate that I'm looking at. There, right in this book, they give us the layout of the bolt holes. The only thing that was missing on here was the angle, and Richard Clark was able to get that off of a blueprint that he had and supply that to us. It's a bolt angle of 75 degrees. So that's how I made the part. Made it on my Bridgeport mill over here in the corner with a DRO, digital readout, and the digital readout is accurate to 2/10,000ths of an inch. So I'm pretty sure that my measurements are dead on. Looking at the tools we're going to use today, we're going to do helicoils. And helicoils are a pretty simple type repair. It's a stainless steel spring insert. See if you can see that. Okay, they're commonly available at Ace Hardware's, anywhere around the country. You can get these parts. They require an STI tap. STI is screw thread insert. This one, right on the tap, it tells you need a 25/64 drill bit. And here's a 25/64 drill bit. It's cobalt steel, good stuff. And today, these are the drill bushings that we're going to use that will pilot that drill bit perfectly into the hole. I want to give you a look at some other tools that are available. And these are called time certs. And the size of the holes we're fixing today are 3/8/16. They are not metric, and these time certs come with a special drill bit, a special countersink that provides a countersink at the top of the hole, and that cuts a perfect little countersink, a tap that will tap the proper size. This is also an STI tap. I'm not sure that's the exact same tap as what's being used with the helicoil kit, so I always keep them separate. And then there's an installer tool. And then the bushing itself is very unique. It is a solid steel bushing, and it has a little chamfer or a little flange here at the top of the insert, if you can see that. That will sit down into the chamfer that's cut by this tool here. Okay, I have a special bushing set up for this drill bit. This drill bit is just a hair larger than the 25/64, so I had to take that bushing and hone it because it's hardened steel. You can't just drill through it. So I had to hone that to fit this drill bit. So that's something that I made myself so that I can use my repair system with either the time certs or with the helicoils. Alright, we're here looking at the engine, and of course now the valley's wide open. We want to be very careful not to get chips down into the valley. So I'll show you what we're going to do here to avoid that from happening. But what I've done is I've taken two studs, 3/8/16 studs, and you have to have good bolt holes to work with in order to hold this and fixture it properly. So I found the best 2 holes. They happen to be at either end. Bury those studs as deep as you can get them so that we're into good threads. You don't want to use nasty threads, and you don't want to use bolts to bolt this fixture on, because if you use bolts, you don't get the all the way to the bottom of the threaded hole like you do with these studs, and you may end up misaligning this fixture. So here's the fixture, and I'm going to pull out the bushings. We'll set the bushing, or set the fixture right on top, and then one at a time I'll drop in these bushings. I'm trying to do this one-handed. Okay, we'll use a couple of hardened washers and some nuts, 3/8/16 nuts. Okay, what I've done here is I've taken my engine stand and I've rolled it, angled it so that I'm going to be able to drill straight down into the cylinder head, and I use my 3M paper taper here and tape off the valley, and I'm going to run a piece of paper over here and drape it over the cylinder head, so any chips that I create I can capture and not let them go in my engine, not let them go in my cylinder head or into this area. So here we go. Come on, stick, would you? There we go. Get that stuck down there good. Run it down on the cylinder head. And now I've got a good surface that I can get to here. Nice working surface. I got my engine stand locked. I'm going to take a 9/16 wrench, snug up my fixture. Okay, and just to show you that these things line up, drop the drill bushing in. I'm going to take a regular 3/8 bolt, and they run right down into the holes. Okay, that tells me that my alignment on my fixture's spot on. Okay, same thing. Alright, drill bushing in place, another drill bushing in place. I'm ready to take the threads out of those and then do some tapping. I confirm that is a 25/64 drill bit. Okay. Probably want to use a little bit of WD-40 when we do our drilling. We are drilling into aluminum, soft material. Okay, set that down. Okay, we've not made it to the bottom of the hole yet. That is a tight fit in that drill bushing. Okay, we are far enough down in that head. Got the chips all cleaned out of the hole. I can look down the hole. I can see that I've drilled to the bottom of the hole. you can pretty much tell when you're at the bottom, the drill bit stops cutting quickly, and you start seeing that there aren't any threads coming out. We're also going to use some Tap Magic for aluminum. I really like this stuff for threading aluminum. You get nice threads when you're done. And all the obvious things that you do with threading apply here. Okay, we're going to lubricate that tap. I'm going to put my little bushing in here, drop the tap into the bushing, and then bushing inside the bushing. We're going to use a tap handle. Put the cap on that, get it out of the way. And here we go. We're going to hold that bushing and very carefully start our threads. Once you get started with these taps, the alignment bushing really won't be needed, but it's that first 2 or 3 threads that you're going to cut that are going to be the critical threads that get you lined up so that you're square this way and square that way to the fixture and to the cylinder head. And that's going to make all the difference in getting that bolt in there and having it clamp that manifold on there properly. Okay, now that we've got some threads started, I'm going to take the tap out, remove the bushing. Now we can tap without the bushing because we've already got our center line established. If you try to do this freehand, boy, you're going to be all over the map. Your chances of success are slim and none. I mean, you'll get a hole and you'll get threads in that hole, but having it lined up on the original center line is going to be difficult. You want to tap a little bit and then back up. You want to make sure that you use a lot of lube whenever you're cutting threads. You back up to break the chip that tap is cutting. When we get close, I'm going to stop, pull the tap out, and clean out the chips that are accumulating at the bottom of this hole. That's going to prevent us from getting threads all the way down. I want to make sure that we've got all the room we need for that helicoil to go in and for it to be effective. Alright, we got all those the threads tapped all the way to the bottom, or as far as I can get with the STI tap. You're not going to be able to get threads all the way to the bottom, but we want to be able to get that insert in there as deeply as possible. So now I need to do the rest of these, but I'm going to go ahead, for the sake of the video, is pull the paper off, and we'll go ahead and put the insert in to show you how we finish that up. So pull the paper carefully, don't get any stray chips. Okay, set the fixture aside, a little solvent from when I cleaned out the hole, and now we need to put an insert in. That's what the insert tool looks like. Okay, it says helicoil on it. You thread the helicoil on here, and it engages that little tang on the end. Okay, and that's it. We're going to use a tap wrench with it and insert this into the hole. And there we go. Now I've got one threaded hole repaired. Let's see if I can take the camera and get a little bit better close up for you. Okay, that's the thread that we've replaced. Put that helicoil in there. We'll go back, and now that that one's done, we'll use that hole to locate for the rest of them. You can see that the rest of those threads are pretty chewed up. My recommendation is when you put these intake manifold bolts on, especially on these because you got water on the two end ports, is put some anti-seize or some lubricant like an oil or a grease, or I'm not sure I'd use the ARP lube, but I would use something to keep those threads from seizing up on the bolts. You got aluminum threads and steel bolts, and you get a galvanic reaction going on there, and the threads want to seize themselves to the bolts, and then you pull out the material when you loosen those bolts. So using some lubricant helps avoid that galvanic corrosion. Anti-seize, I think, would be probably about the best to use for this application. Alright, we're going to do one more thing here. I went and completed all the rest of the holes, and I had a problem with this one and with this one. And what I ran into with this one is I did not tap the hole deep enough. Didn't tap it all the way to the bottom. I must have encountered some chips or something. Thought I was to the bottom, but I wasn't. And when I put the thread insert into that hole, the fastener would start in, go in great, and then all of a sudden bind up about halfway down. Found out that what happened was at the bottom of that thread insert it was tighter than at the top. So I had to pull that insert back out of there, which is not always that much fun, but I was able to grab hold of it and pull it out. Retap the hole, ran it to the bottom. Ran into a different problem in this hole. What I ran into here was I had not drilled to the bottom of the hole, therefore I didn't tap to the bottom of the hole, and so now it was a matter of pulling that thread insert back out of there, drilling it to the bottom, and then retapping it to the bottom. And then the inserts went in all the way to full depth, and now they work perfect. The other thing I didn't show you was at the end of the insert, there's a little tang. Okay, and that tang also has a little notch cut in it. Not sure you can see that notch or not, but it's right there. That tang is there for installing the insert, and you have to knock that tang off. And the way I'm going to do that is I'm going to use what is this? What size is this? It's probably a 1/4 inch. It is a 1/4 inch punch, a hammer. I'm going to put that punch in there. Let's see if I can do this with hold the camera. Give it a little whack, and the tang breaks off and ends up down at the very, very bottom of that hole. Let me get a light. I don't know if you can, that makes it easier to see or not, but I can see down that hole, and there's the tang broke off. Now you got to fish that out of there, and what I'm going to do is I'm going to use a shop vac and some compressed air, or I could turn the engine over, but hey, if this is installed in your car and you're doing this in the vehicle, you can't quite turn it over. So anyways, that little thing's got to come out of there, and then our fasteners, studs or bolts will thread all the way down to the bottom. So that's it. Hope you enjoyed the video. If you like what I've done here, press the like button and share this with other Turbo Buick guys. Thanks.